We're now going to switch over to two talks in a row that'll cover the use of Dafny in teaching. So I think this is an exciting point of discussion. So our first talk will be by Ron Ettinger. We're talking about teaching logic and set theory with Dafny.
Thanks, Joseph.
If you could just try to speak closely.
And let's see
Yes.
if it's being projected.
Okay, let me see. Yeah.
If my... How about the font size? Is it readable or should I... A bit bigger? This way.
This is great.
That's all right? All right, so thanks, Joseph. Hi, everyone. So happy to be here speaking about the way Hezi, Daniel, and myself have been using Dafny in teaching a second-year computer science course on logic and set theory for the past 3 years. So this is now the third iteration of the course, approaching the end in a couple of weeks, in a small college in Israel called the Israel Academic College of Ramat Gan, my birth town, near Tel Aviv. And I mentioned that it's a small college because it's a new computer science program. And the benefit of that was that it started small, and I was given the opportunity to teach a couple of required courses the way I wish to teach them. And I wish to use Dafny. The reason I wish to use Dafny is that I've been using Dafny for the last nearly 10 years for teaching programming, verified programming with refinement, correct by construction programming, stuff like that, at Ben Gurion University. And I love it. So I thought, why not use it also for the required courses? And in a big university where you have many lecturers for the same course, it's not really feasible. Here in a small program, it worked. So specifically for set theory and logic, we run this course in two really different parts in parallel. So there is one way we've been using Dafny for set theory. I will show it a little here, and a different way we've been using Dafny for the logical part, for propositional logic. And recently I've seen mid-December teaching material from Amazon being published online about how they've been teaching Amazon developers logic, propositional logic, specifically deductive or natural deduction. So really inference rules, how to use Dafny. And when you prove something, you really make small steps that you are aware of what's known and what's needed as if it were a sequence like by the book. And I've been doing the same, but in a different way. So I will say some words about that as well. So I would like to say, so I've seen in this material that was published recently that Dafny is being spoken of as a programming language, as a proof assistant, and as a language for writing correct code, so verified programming. And I would like to say that we've been using Dafny as a programming language. I will try to say how, as a proof assistant as well, but also as a teaching assistant. And that's my main message today. How Dafny can be a teaching assistant, how it can help the students get feedback on their assignment submissions ahead of submitting the assignment, really get the feedback that everything's fine, or if there is a problem, maybe there is a deadline and say verify false and sorry, but if not, they have good confidence that the programs are correct. It also helps me in grading. Is it good or not? Well, I would like to say some words about the grading, what kind of parts of the grading Dafny helps me in a really nice way. It doesn't automate everything, not at all, right? So it just helps me a little bit in really funny ways. And I'm not broadcasting now because there's some issue here with with my, I didn't touch my laptop, so it went to sleep. Okay, that's it. Yeah, okay. So this is kind of background, and what I've prepared here is a few examples. So a few examples. I'm teaching the set theory part with inspiration from the course I learned at Ben-Gurion University by Professor Uri Avram, and the logic part by the Huth and Ryan 2002 book, and in two different ways. And Hezi helps me with this. So let's see what kind of examples I prepared here. I prepared here examples from homework assignments. So I have here links to, I'll make it a bit bigger, or can you see? Anyway, I'd like to show some examples, and then you can browse later. I just uploaded it to GitHub last night so that it will be freely available, because I thought there's so much I'd like to say. How can I say everything in 15 minutes? Of course not. So everything is linkable now, all the material from the course. I deleted all the Hebrew wording from the comments last night, and I hope I haven't missed some, but bear with me if I did. And the nice, so there are really some nice things to share, and you'll be able to see it later if you want, or speak with me until the end of today. So examples. Let's go. Let's look. Some set theory. So right, distributivity of union over intersection. Right. So Dafny already helps me with the primitive support for sets, even for infinite sets, with the operations for subset, inclusion, so unions, intersection. So I can express such a property, and then we can prove it. We can prove it, and we've been using most of what's available on the short article on different. I linked it here on different. Sorry. On Rusten's different styles of proofs column, right? There are different styles of proof, and we've been using all of them, and it's fun. So going back to that example, we can see here some, right, so I've been asked. And the most important thing is that in this part of the course, Dafny helps me too much. It proves things by itself. So what is the student taking away from this? So I've used the labels and the reveal, and I insist in the assignment description, please write a proof that is for the human reader, and try to hide the preconditions for a lemma, the assertions with labels, and reveal them in such a way that, well, I will have to read the submission by myself to be convinced that it wasn't too much the help of Dafny there. But it works really nicely. And then there are all kinds of, so what else we have here? The for all ensures construct, really nice. The calc, I love the calc. Most of my PhD thesis was written with calculations, but on paper. Did anybody read that? Don't know. But then at some point we wrote it in Dafny. Yeah, some of it. Anyway, yeah. Case analysis with if and else. So it's like programming, right? And labels, and then we prove. So all kinds of really nice features for proving correctness, but Dafny helps a little too much, so hiding with labels and reveal. And then I have some examples here. Let's see. For example, that set difference is not associative. So here's a lemma. The assignment asks for a lemma that returns a result. So an existential, like a witness, for the fact that the set difference is not associative, right? So the student needs to assign values to the result parameters from this lemma that will make the property hold, that will demonstrate that set difference is not associative. So that's really nice, and then I'm showing them how to prove in the solution, how to write such proof either with calculations on Booleans or calculations on sets as well. Let's see what else is really nice that Dafny helps me. That's simple. Right, bijective functions and cardinal equivalence. Okay, so what is cardinal equivalence? So what does it mean? The two sets are cardinally equivalent. It means that there exists a function from A to B that is bijective. Okay, so we used Dafny to define what it is for a function. A function as a relation, a binary relation is taught as sometimes as a set of pairs. So we have sets, we have pairs, we have I sets for infinite sets. We have set comprehension. So we can do all those things really nicely with Dafny. And what did I want to say? The set comprehension is so strong, and the infinite set comprehension, and the ability to express an existential quantifier, to quantify over sets. This is what has helped me to teach the last part of the course, the diagonalization of Cantor, that there's no surjective function from a set to its power set. And Uri Avraham, in his course in Ben-Gurion University, wrote that on the whiteboard with 4 lines. I wrote that with Dafny the same way, in 4 lines. That there is, and it works. I love it. So this is about sets. Let me pass on to the logical part, which is more recent. So it's the 3rd year running for this course. The first 2 years, only the set theoretical parts were demonstrated in Dafny, and I've used Dafny to show how to prove things. And only this year, we've started formalizing the natural deduction. So here we teach the proof really in a very precise way, and there are lovely stories to tell about that. So I want to show that. Let me show it. I show it here, maybe. Maybe I'll show it here. I have it here. So just by the book, we can write a proof of a sequent. Sorry about that. A proof of a sequent. So what is the sequent here? Let me browse for a shorter one. Let me start with a short one. Yeah, a short one. Just saying that if we know that P implies Q implies R, and P implies Q, we should know that P implies R. And there is this short proof here in 7 steps. And so here we've been using Dafny in a different way, like embedding in it like a domain-specific language for formulae. So this is the difference between the way we have formalized natural deduction than the way done at Amazon. The way done at Amazon is great to teach people to prove things in Dafny. I'm trying to teach students to prove in general propositional logic sequence. So we go by the book, and the formula is a data structure. We have a little parser and going back to strings. We have the proof is a data structure, right? So the proof, the tree of the proof is a data structure. It's just a pair of the result and the justification. What is the justification? There's a data type for the rules, for the inference rules, and they speak. Huth and Ryan describe 15 rules for propositional logic. So we've used Dafny for that. And what I'd like to show about that in a larger proof, right? And those little, what they call boxes are for temporary assumptions. You temporarily assume, for example, not P, and proof by contradiction, you reach a contradiction. I couldn't find the character for bottom, so I wrote F for false. But you reach bottom. At the end of the box, it means that you can conclude that the negation of your assumption holds, or if the assumption itself was a negation already, you can prove by contradiction the property itself. And so we can prove. So the fact that we can now print out proofs, as the proof is a data structure, allows the students to come up with the proof and try them out without understanding how how I implemented the domain-specific language. It's not really important. They don't need to understand Dafny to a large extent. All they need to do is copy-paste from my examples. I showed them very many examples, and then do the exercises, and they manage. And then they manage, okay, one thing they managed that was interesting to me as a teaching assistant for me is in grading the first assignment. In the first assignment, I haven't said anything about Dafny, just on paper to write some sequent proofs. And there was an optional bonus exercise that I proved by an ugly case analysis in 31 lines. So this is this ugly proof. 31 lines, and then I see in the submissions of the students, it's done in pairs, one pair submitting a solution in 14 lines. And I look, and I taught them, right, so you try to prove according to the structure of the result, and if that doesn't work, maybe prove by contradiction. If that doesn't work, case analysis. And they did proof by contradiction in 14 lines. Now, that was presented on paper, so Dafny helped me. This proof, the same property, what does the property say? Intuitively, I didn't even know it was correct. What does it say here? It says that if P and Q implies R, then P implies R or Q implies R. If you have intuition for that, great. I don't. So it took me 31 lines to prove this, and they did in 14. In 14, with assuming the negation of the result, and then reaching one contradiction, and then reaching another contradiction, and beautifully, they have a 14-line proof. I don't need you to read actually the proof, although you can afterwards, but what helped me is I immediately typed it into Dafny. And I asked Dafny, is that correct? They made a couple of typos with the brackets, but I fixed that and it works. So it's nice. I teach them how to debug the proof. So the proof really looks like that. I have to show you, and then I have to conclude in about 1 minute. So just before concluding, I'd like to show you how it looks, the proof, and then how, just a hint that they can debug proof. So sorry, I'm not in the right place. I want to go to the short proof. Here is the short proof. Oops, sorry, what did I do now? Don't know what I did. Click the wrong thing. So just to show you how, maybe the shorter proof is more important to see. No, so here I show the printout of the proof, but where is the actual proof here in the code as Dafny code? It looks, one more, there's the sequence, there's the proof. Okay, I made some comments here, but it looks like steps. Okay, instead of the formula in textual representation, it's a data structure, like prefixed the root of the formula, and like a tree of the formula is. So they can write the proofs, and then I showed them, if Dafny says, there's ensures that the proof is correct. If it says, I cannot prove this post condition, you come up for each step is a line here. Each step you can, it's a local variable, you can assert that it by itself it's a correct step. And the assertion that tells you, no, I'm not convinced, you know that you need to fix it. So they submitted, yesterday they submitted one of the pairs that submitted a solution to a proof that was not, that did not verify. And I looked at the justification for one of the steps. All they needed to do was to reverse the arguments to the justification, and it would be fine. So it's really, you need to take care of the details to get convinced of the correctness. What's for the future? I have a slide for that. For the future, well, compare it with how logic has been used for teaching, or proof assistants have been used for teaching in Lean, in Coq. To be honest, I don't know. So it's out here, and let's think, and let's think, what are the advantages? So Dafny is a programming language here because I have the main where I print I print out the proof and the formula, also the truth tables. I have an example here that given any formula and the variables, we generate all the combinations of truth values to the variables and the last column of that formula in the truth table. I have to finish. So I will just say that Dafny has helped, hopefully helping the students. They don't all like this. It's a burden, but it helps me. And it will be interesting in the future to do the same for first order logic, predicate logic. I tried, but it's harder. Substitution on the tree of the formula, it's harder. So hopefully this will be one of the next steps. Thank you.
Okay, maybe James can set up and in parallel if there's one quick question.
I've got a quick question, actually. How many people did you have in your course?
Now it's 70 people in 2 groups. Yeah, it used to be between 30 and 40 in the first couple of years.
Okay.
Yeah.